Yes. Sir? I'm coming back to you in just a second. All right, so right now, those of you that are in the front, what you're going to do is you're going to go to page number 42. So what I ask you to do is I ask you to look at the example, right, guys? Figure out what's going on. And once you get that done, I want you to start working on number 11 through 14, okay? I'm going to go to the back to explain to them what they're doing, and then I'm going to come back to you, and we're going to go over the answers. Is everybody good? Okay.
Hey, this one.
Yes.
I didn't get to run. I was supposed to be there at 3 o'clock. It's little.
So we got this. I think I'm just good to be sure. Yesterday with the dot.
All right, everybody ready? So right now what you're doing is you are looking at this sample problem. So let's go over the sample problem together. And then from there, sorry, give me a second. Then we're going to go over the practice problems. Now, so what you're going to do is you're going to take your one pager that you had and you're going to add these example questions to it. So if those of you that just got online, what we're going to do is we're on page 42 of your textbook. Now, if you're having a problem getting online with the textbook, I do have permission for you to come and pick up your textbook or have someone take the textbook to you. So if you would just send me a message and let me know, hey, I need to either get it or this. Let me know what needs to be done and I will do it for you. Okay, everybody at home. Okay, so if we look, it says here, it says, when did the runner whose motion is described in figure 11 reach 12 meters beyond the starting point where she was at 4.5 seconds? So the first thing that they say to do when you have these example problems, you need to restate the question. Now, you're not going to have to write this down. You just have to go and look at it. Okay, guys? So it says, at what time was the magnitude of the runner's position X equal to 12 meters? So if you look at that, what you would do is you would go, and it's asking you for the time at 4.5, right, guys? So the time is on the bottom, so you go across. 4.5, you see the line, right? That little dotted line, you go up to that dotted line to where the line crosses, and then you go left to that dotted line, and that's going to tell you your number. So what is the position they were at that time? Mm-hmm. Yep,
Yeah.
that's it, 22.5. So the next one says, what was the runner's position at 4.5 seconds? So you're going to go over to 4.5 seconds, go up, go across, and what do you see? I see 22.5. Do you see that? So what you do, are you ready? We're right here doing examples right now. So what you're going to do is you're going to move this over, go up and over, and that's how you found your answer. Is everybody good so far on how they did the example questions? Okay. So number 11 says, the graph in figure 12 represents the motion of a car moving along the highway. Describe in words the car's motion. So if we look at figure 12, this is a position versus time graph, right, guys? Mm-hmm. So what is going on with him? What do you think the car's doing? He's going back somewhere, right? He's going in a negative position, isn't he? Because he's going down. So like we had talked before, remember how we had these maps when we were talking about in a group? If it's going down, if you're looking at position versus time, so this is your position, this is your time. If it's going this way, that means they're going in a negative direction, so that means they're going back. Is everybody good so far? On your paper, did you write that down? So what I did on mine is I wrote down what the question number was, what page I was on, and what the answer was. Is everybody good so far? Okay. Now let's look at number 12. It says, draw a particle model motion diagram that corresponds with this graph. All right. So we're doing a particle model, right? I'm going to try to use black so everybody can see. So on mine, for number 12, I had 125 meters. I had an X here. I had 0.0 meters. And what I had is I had a line going all the way down. Also what I had is I had dots. Is everybody good? Is that what you drew? Chandler, is that what you drew?
Yes.
Okay. Does everybody understand how that works? Now, my time over here is time 0, or my time initial, I'm going to say initial, is 0.0 seconds, right? Over here, my time final is 5.0 seconds. I also included that to make sure I understand I have my position, right, guys? 125 meters. He went from 125 meters to 0.0 meters, and he did it from 5, right, 0.05 to 5 seconds. Is everybody good with number 12? He was going toward it in a constant speed. How do I show he was going in a constant speed? Is the sections in between, the circles are about the same. Is everybody good with question number 12? Okay. Let's look at question number 13. Question number 13 is answer the following questions about the car's motion. Assume that the positive x direction is east. The origin of the negative is x is west from the origin. So the first thing I'm going to do is I'm going to draw myself a north, south, east, and west. I know this sounds juvenile, but can I tell you, if you do that, that'll help you out. Okay? So then I go back to the problem on what it says. And it says, assume the following questions is about a car in motion, assuming that the position x direction is at the east and the origin is a negative x direction to the west of the origin. What was the time of the car at position of 50.0 meters east of the origin? B was, where was the car at the time of 1 second? And C, what is the displacement of the car between the time 1 second to time 5 seconds? Now, what are we referring to here? What graph are we referring to? All these problems, we're going to refer to figure 12. Do you see figure 12? Now, I'm going to draw figure 12 up here for us so we can see it, okay? And if I got it wrong, you let me know. Okay. So the question says, at what time was the car's position at 25 meters east of the origin? This is east, right? So what do you think we've got here? What do you think the answer to that question is? I have down 4.0 seconds. I took my 25 where I thought it was. I drew it to my line, right, guys? And I drew it down. So the answer to question 1, I got 4.0 seconds. Do you see how I got that? I was just using the graph and reading it. Okay? The next question asks me, where was the car at 1 second? Well, I'm going to go to 1 second. I'm going to go up. I'm going to go around. Everybody agree 100 meters. Okay? So B is 100 meters. Number C says, what was the displacement of the car between time 1 to time 3? How am I going to do that?
75.
It is 50. How did you get 50?
Because at the time 3 is at 50 and the one is at 100.
So if you look, we're looking at position, right? 100 minus 50 is 50. Is everybody good with that? So we did position final minus position initial, and we subtract those two, and that's how we got our 50. Good so far. Okay? Let's look and see what it says for number 14. The graph in figure 13. So now what I'm going to do is I'm going to erase this one. And I'm going to draw on the board the figure that it's asking for. You have yours in your book, right, guys? Okay. So what I have is I have position on this side in meters, right? But this time I have a T type of form, right? And so this one has time in seconds. Everybody good so far? Now, when you look at this, are you ready? This line that goes across, this is at 0 position. Okay? It doesn't say it, but that's what it is. So here, we have A, right, guys?
Yeah.
Here, we have B. Now, if you think of it as a race, like you're on the track, okay? And you have somebody, and you have a starting line, right? You have a person that's in front of the starting line, and you have a person behind the starting line. They're at two different positions, aren't they?
Yeah.
That's what's happening here. Is this making sense to you? Okay. So it says here, the graph on 13 represents the motion of two pedestrians who are walking along a straight side of the city. Describing to words the motion of the pedestrians, assuming that the positive position is east of the origin. When I say origin, it means at this right here. They're both kind of walking east, aren't they? So how can I describe this? How I do this is how I do it this way. I'm going to say this is a football game, and this person is on the 50-yard line, and I'm going to say of the other team. Okay? And I'm going to say here is the middle of the field. This is a negative 50-yard line. That means they're on their own side. So got one on one side, one on the other. They're both running to the goal line. Does that make sense?
Mm-hmm.
So that's what I'm going to say. I'm going to say that these two people started two different places. Okay? Now, do they ever catch up with each other? No. Are they at a constant velocity, though? Going at a constant velocity. And that's all I need to say. Is everybody good with what happened on this page? Okay? So now what we're going to do is we're going to turn it to our other page of the reading. We're going to go to page number 45 now. Okay? So go ahead and go to 45. Now, page, and what I did with mine is on my ISM book, I just drew a line where that stopped, and I put the page that I'm using now. So I can tell which one went where, okay? So now, right now, we're on page 44. Example problem 2. So it says here, a graph is at the right describing the motion of two runners moving along a straight line. The lines represent their motion and labeling A and B. That's where B passes A. So I'm going to do it really rough. So we have position here, and I'm on the sample problem. We have our axis here at the origin, right, at the O line. And then we have negative 50, negative 100. We have, I think it goes in 50. So 50, 100, 150, 200. And so what happens is the person on A starts at the origin, don't they? Possession B actually started behind the goal line, but what happened?
They intersect.
They kind of intersect. Whoop, too far. They go further than that. They kind of intersect over here, didn't they? So this scenario is a little bit different, isn't it? Somebody started on the line. Somebody started below that. They both were running, but this person was running faster, weren't they? Because they caught up with them, and did they pass them? Yeah. Do you understand what happened in here? And that's what it's explaining there. It's telling you what's happened with them. So let's look at practice problem number 16, and we're going to be using the graph that's over here. This graph's a little bit different. So this is a position time graph. We have our position over here, and that's in kilometers. We have our time in hours down here, right? We have 0, we have 0.5, we have 1.0, we have 1.5, and we have 2.0. We have 1.0, 2.0, 3.0, 4, 5, and 6. We have 2 people, don't we? Did they start at the same place?
No.
They did start at the same place. But what changed this time? They changed it. They started at different times.
Yeah.
So think of it this way. I and somebody else is waiting to go. All right, I'm in a track meet. The little gun goes off. That person goes first and I go after them. That's what's going on here. This person here, Janita or whatever her name is, she actually left first, didn't she? Do you see the time at 0? If you look at Heather, she didn't start until 0.1, did she? My goal at the end of the school year in this class is that you'll know how to read a graph, okay? Everybody good so far, so we know the answer so far. So number 1 says, where is runner 1 located at T is 0? Well, they're at 0, aren't they? They're on the line. Which runner was ahead in 48 seconds? So we go to 48 seconds. Can we tell what 48 seconds is? So who do you think would be in front? I think Heather would. I think Heather would. Because what we would have to do is we would have to continue this, right? All right. Do you agree that maybe she would be further along than the other one at that time? Because that's hypothetically way back then, isn't it? All right. The next one says, when runner 1 is at 0 minutes, where is runner B? Where's runner B at?
Wait, you said what?
At 0 minutes, where's runner B?
Like 6 minutes?
Runner B is at the same place. They're both at 0, aren't they?
Yeah.
Okay. Remember, it's checking to see if you understand that this is position. They're both at the same position. They're both at 0. They're just starting at different times. And they're trying to check to make sure you understand that. Okay. And then the next one says, how far away were runner A and B at 20 seconds? Okay, so, this is the thing I want you to look at. Do you see what this is? This is hours, isn't it? Didn't see that. Did you see that? Okay, so let's think about going back to the question again, and it's asking us at 20 seconds. 20 seconds would be where? This is a half hour, right? So 20 seconds would be here. So if I go up, I'm looking at seeing where they are at. Okay? If you look, where's Heather? She's like 1.5, right? Where's Janita at? 4.5. Who was ahead? Janita, right? Do you understand? This is in hours, right? They're asking us questions in seconds. We were thinking before that this was seconds, but these are hours. So we have to adjust everybody good. Okay? And then the last one, which was the challenge, we're not going to worry about. The question that I want to ask y'all, because remember, we're getting ready to rotate. Sorry, Kristen. Do you understand what we did today? Okay? So what you're going to do is you're going to go back to the back and get in your lab station. Those of you that are back at the lab station, can you wipe your station down and come sit down? You're going to finish the lab that you were working on yesterday, and you're going to start the handout. Remember the pages that we're doing. Those of you that are coming over, come on over, and you're going to start doing the math, and I'm going to talk to the people online for just a minute. All right, guys. Number one, you stay right there for a second. If you cannot get online because you don't have your textbook's not allowing you to, today, Mr. Harris is going to put your names in your books, and I will have them in front. So if you want somebody to give them to them, or if you want somebody to come by and get your textbook, you can do that, okay? The next thing that I want to do, and I'm going to stop recording. Give me a minute. Yes, ma'am, you can.